Hey, what is up everyone? Welcome back to another video. In this video, I'm going to give you a detailed walkthrough of the room down over on Vulnlab. This is a machine that's rated as easy on Vulnlab, but I would say it's maybe a little more medium. There's parts of it that's easy, parts of it that you really need to think through, but I really enjoyed the process of going through this room, or through this machine. Now, to be clear, I'm not doing it live right now. Well, technically I'm live streaming, but I'm not going at the machine for the first time. I've already solved it. Now, if you want to see me work through this machine live, I did do it on live stream. So right now it is January 4th. So if you go back on my YouTube channel to the live streams, I worked through this machine live on my January 2nd and January 3rd live stream. So whenever this standalone video finally releases, if you want to see my full methodology when I approach this, go to January 2nd, January 3rd, on the live tab, and you'll be able to watch me work through this machine. But this video is going to be a standalone walkthrough of how I solved it, but I want to use this opportunity to also teach. So I'll teach through proper enumeration, proper hacking mindset, and all of that fun stuff as we dive into this machine. Let me go ahead. Cypher said, cover the mic when you cough, please. We don't need to catch anything. My bad. I am getting over a cold, guys. So I do apologize for that. I'm almost over it, but I still have a nice cough. Let me go ahead and share my screen. The first thing I've done is I just have my notes set up here in Notion, and that's what I use for taking notes. As far as note-taking goes, it's less important what platform you use and just more important that you actually take notes. So whether it's Notion, Obsidian, Cherry Tree, OneNote, choose your note-taking thing. Just make sure you are consistent and you actually take notes as you work your way through machines. But the first step when we approach a machine like this is we want to see what ports are open. So I'll open up my terminal here. You can use Nmap. I like to use Rust Scan and then pass it over to Nmap, and here's how I do that. We'll do Rust Scan like this, -A to pass it our target, and we'll do down -VL is our target, and then we say, hey, whatever open ports are open, pass it over to Nmap with this flag right here. So this is the Rust Scan command. Rust Scan, I want you to see what ports are open and /VL for Vulnlab, and then I want you to take any open ports, pass them over to Nmap, and then run the -A flag with Nmap to enumerate all things on the open ports so we can begin our enumeration. While it's doing that, let's jump over to our notes and begin getting our notes set up. We'll do H1 here for enumeration, and we'll do H2 for our Nmap scan. The cool thing that I like about Notion is as we do stuff, it will create a table of contents over here on the side for us, and we can easily see where we're at. The other cool thing you can do is we can actually add a table of contents in the beginning, and then when we open up our notes, we can very quickly see, hey, here's what we did. We can jump to Nmap scan. Obviously, it's not going to do anything for us now because we only have that. But these are just some of the cool features I like about Notion. And I also just use the free version of Notion. I don't pay a sub at all to Notion, so I don't use any of the paid features. So everything I do on this stream, you can do completely free of charge. You can see our scan is done. We have a SSH on port 22, and we have a web server running on port 80. Let's go ahead and scan, or grab the main stuff from our scan, drop it into this. I'm going to change this over to bash, and we'll separate these. And let's just begin by doing some basic enumeration on the ports that we see are open. Now, anytime we see SSH being open, it's likely not going to be the initial way into a machine, but there is some things we want to check. We can do some basic banner grabbing, which is what this did for us. So if we were doing a pen test, we could look this up to see if there's any vulnerabilities, but I can tell you there's not going to be anything interesting for this version of Open SSH. But what we can check is whether or not password authentication is enabled. When I do a pen test, especially an external network pen test, which is when a client just gives you a bunch of public IPs, if you find that SSH is internet facing, you want to see if it allows password authentication. If it does, it's actually something you would report on a pen test as an informational or a low finding depending on the context. So let's go ahead and do an H2, and we'll say SSH on port 22, and let's first just see if password authentication is enabled on SSH, and that'll be a good thing to know in the future, because if we discover a password, we know to pivot back to SSH and see what information we are able to find. So we can just do SSH root at down.vl, and you can see it asks for the password. It shows us, yes, password authentication is enabled. I'll copy that, and we'll just say password auth is enabled, and we'll drop our notes right there for it. But what we're going to spend most of our time on in the beginning here is looking at HTTP. We have a web server running on port 80. We can see right away it's Apache 2.4.52, which is a pretty up-to-date version of Apache. There's likely not going to be any crazy RCE for our initial access, but always something worth checking if you're doing a pen test. Anytime you see version information, take the time to look up the version information, see if there's any CVEs that you might be able to discover as an initial foothold in. But I know here there's nothing like that, so we'll begin with a few basic scans. The first scan I like to do anytime there's a web server open is dir search. So I'm going to go ahead and create a new section here, and we'll call it dir search, and I'll create a placeholder there. We'll put in the results for dir search, and I always like to see if there's any vhosts or virtual hosts that might be configured, and we'll make a thing there for vhosts, and we'll make another section, and we'll just call it the website itself. So we'll say website features, and when we get to browse into the website, that's where we'll put our notes there. But let's go ahead and begin with dir search. We will open up our terminal here, and I like to keep my terminal tabs named. This is just a peculiar habit of mine. You obviously don't have to do this, but we'll go ahead and do dir search /u, and we'll do down.vl, and we'll let that do its thing. We'll open up a new terminal. I'll call this vhost, and I actually created a vhost scanner, but it's just literally a wrapper around ffuff. I use ffuff for scanning for vhosts. I just always forget the syntax. If you want to grab my scanner, you can get it from my GitHub. If you go to github.com and Tenebrae93, for those of you watching the live stream, I will drop it in the chat. But here, you can go to my offensive security repo, and I have a vhostfuzzer.sh right there. So the vhost fuzzer I'm going to show you is that one there. You can grab it yourself if you want to use it, but we'll just go to tools. You can actually see it from when I used it in the past, vhostfuzzer-h. It just asks for the domain, wordless, URL, and FS filter. So let's go ahead and run this tool against this domain. Our domain is going to be down.vl. Our wordless, we can just use share wordless dirbuster, if I can type, directory list 2.3 medium.txt. URL is going to be build.vl. FS filter we don't know yet, so we'll just say 1. And it doesn't seem to be processing any. Oh, look, I did down. I did build instead of down. That was my mistake. Let's change build to down. There we go. So the FS filter just means filter by size for vhosts that don't exist. We know that the vhost doesn't exist. It's the size 739. So we're going to update the 1 right here. We're going to change that over to 739. And now we have our vhost fuzzer running. From here, while our scans run, we can begin actually looking at the web server. You can see that dir search already completed. So we can grab these results here. There's really nothing interesting for us, but we'll at least grab them and drop them in there. But now we can begin looking at the website. Now you can use Burp Suite, you can use OWASP Zap. I like to use Kaido just because it's a little more affordable than Burp Suite Pro. Well, actually a lot more affordable because Kaido, the free version of Kaido doesn't rate limit you on things like intruder attacks. But let's pop open Kaido. I'm going to create a new project. We'll just call this down for YouTube. And we'll go over to Intercept. I'm going to open up the browser. We'll launch Chromium. Close this extra one, and let's go ahead and see what is running on this website. We'll go to http down/vl, and we have something like the down detector. It says, is that website down or is it just you? Now, for those of you watching on live stream, and for those of you watching after the fact, this standalone video on YouTube, before I tell you the answer, I want to ask you, what are some things that would be obvious to check here? We already did dir search, so we know there's no good directories that we could dig into. We have this, please enter URL. We can look at the source code, see if there's anything on the source code, but you can see nothing too interesting for us on the source code. What should we check here? Well, answer is, anytime you see an opportunity to enter in a URL, you want to see if SSRF is possible. Can we do server-side request forgery? Can we get the server to either reach out to us or itself? And can we enumerate any information that way? So one way we can do this is we can set up a netcat listener on port 80, and we'll just see if our website is down that we're hosting ourselves. So let's go ahead and do that. We'll open up our terminal here. I'll just change this over to terminal. go over to here, and we'll do a netcat listener on port 80. We'll jump over to this, and let's enter in our IP. Yours is going to be different than me, but my VPN IP is up there. So we'll do 10.8.4.163. And we'll click is it down. And when we do that, you can see that we do actually get a hit from the web server. And what should stand out to you, and if you watch my live stream of me going through this machine for the first time blindly, I actually called this out right away. So I recognized this immediately, but then fell down kind of a rabbit hole. But what stood out to me is it's actually using the curl binary to see whether or not a website is up or down. So all it's doing is this, curl HTTP, and then 10.8.4.163. You can actually see my fuzzing from when I was trying to figure this out myself, but this is all it's doing. And if it fails to connect, it's going to say the website is down. If it does connect, it's going to say that it is up. But you can see it says fail to connect. On the other hand, if I curl something like down.vl, we're going to get that information. It's going to say, hey, the website is up and it is listening. Now, there's a few things that we could check here. One, we could try if we can fuzz localhost. Generally, if you have anything set up that allows you to see if a URL is alive as a developer, you want to make sure the attacker cannot hit localhost. I have discovered SSRF, honestly, more times than I can count on real web apps, including like on full public-facing websites that allow me to do a port scan internally. And I'll show you what I'm talking about. If we do is it down right here, you can see it is up. That means this is vulnerable to SSRF because we can hit localhost. And usually when you can do that, you can actually do port scanning. So for example, if I do localhost 80 on port 80, I'm just going to copy that and do is it down, you can see it's up. So we know that internally port 80 is open just like it is externally. But sometimes you might have a web server that is not internet facing, it's only open internally, but the way SSRF works is the server itself is making the request, not us. So let's pretend for a moment there's a web server hidden on port 8000. We can't get to it because there's a firewall in place that prevents us from the internet hitting web server on port 8000. But if there's a web server internally on port 8000, we can use SSRF, hit localhost on port 8000 and see if it is up. In this case, that's not going to be the way in, but that's the rabbit hole I fell into when I was doing this machine live. But it is a valid threat vector that I see in the real world when I'm able to do SSRF. But what we need to dive back into is curl. It's using curl, the curl binary to execute commands, which should cause us to think, how is it doing that? And how does curl work? Well, let me show you something. One thing that you can always try is file etc password. Anytime you have SSRF, that's worth trying, but most of the time it doesn't work. You can see only protocols HTTP and HTTPS are allowed. So we can't just read files that way, but look at this strange behavior from curl. It's not really as strange as intended, but it was something I wasn't aware of until I went through this machine. If I curl down-VL and then do file, I think it's like this, etc password, no such file or directory. Let me add another slash there. Oh, that still doesn't work. Localhost. There we go. That's what I'm trying to do. So what curl is going to do is it will take up to 3 parameters here. So we could do curl build VL, down VL, and file etc password. And it's going to try to curl both of these. It's going to take a while. I'll just stop it because it's going to fail on build. It's not going to be able to hit it, and it will be able to hit that one, and then it will grab etc password. But curl will take up to 3 URLs and try to curl them and get the information from them, which means we can actually read files if we're able to pass it file etc password. Now, going back over to this, if it's only executing curl, so when we pass it, hey, is this website down or just me? It's going to do curl HTTP, our IP here. And then, depending on how the command's being executed, if it's just passing it straight to curl, we might be able to bypass the HTTP restriction by saying, hey, also tell us about etc password. See if we can get remote file read on this machine. And let me go ahead and see if that works. I keep clicking the wrong thing there. We will open our own basic web server so we can see the request when it comes through, but let's give this a shot. We'll do HTTP. You can see my IP right there. And let's do a space and do etc password and just click is it down. And look at that. We have file read on the machine by abusing how the curl binary is being used. Now, it's always important to take good notes. Let's go ahead and take good notes on this. I'm just going to add the payload I just used up here, like so, and we'll grab a screenshot of this. What I like to use for screenshots is Flameshot. So we will do that. We'll grab this. We'll highlight this right here, and then we'll, of course, highlight we have full file read on the machine. Now, when I was talking to, here, let me add this real quick. When I was talking to JKR, who is the creator of this machine, that's a very big image. He added this to the machine because this is a way he got a real CVE in the real world. He told me that he was working on a network appliance and he realized it was doing something similar to this. So this attack that you're looking at right now is very real world, something that you might encounter when you're doing CVE hunting or doing an actual pen test. So once again, one of the reasons I really enjoy Vulnlab is all of the attacks you come across are things that the creator of the machines have likely come across in the real world doing pen testing and red teaming. But you can see we now have file read. Now, you could try to read a bunch of different files. One file that we could try to read would be something like Alex. So we see Alex right here. It's likely executing our commands as www-data right here, but just maybe Alex has like a private SSH key that we would be able to read, and we could try that. If we do home Alex SSH ID RSA, that's always worth trying. We can click is it down, and you can see it doesn't work, likely because we don't have permission. So let's go back to etc password. And since I said before, we're likely running this as www-data right there. Look up above at the URL. There's an index.php. Now, if you're new to this world, it's a little bit confusing, but you have client-side code versus server-side code. Client-side code are things that you can see. So if I right-click on here and do View Page Source, this is client-side code. This is HTML, hypertext markup language, JavaScript, maybe some CSS for the design, but this is client-side. In other words, you are able to see it. You are able to modify it. You can look at it. There's nothing secret about it. At least, usually there isn't. I've had a few times where I discover some things in the client-side code that shouldn't be there when I'm doing a pen test, but generally there is nothing secret there. PHP, on the other hand, is server-side code. This is code that is only exposed on the server, and if you're able to read server-side code, well, you might be able to discover some interesting functionality that wasn't available to you looking at the client-side code. So with that, it would always be worthwhile if we see something like index.php to read the server-side code. We know that we have file read now, so we're able to do that, and we know we're likely executing these commands as www-data at var www. So let's go ahead and give that a shot. We'll go back over to here, and we will do var www html index.php, and we can click, hey, is it down? And you can see it actually passes us the server-side code. I'm going to grab a drink. Before I give you any answers, and I'll zoom in for you, I want you to look at the server-side code and see if there's anything that stands out to you. And for those of you watching on the live stream, feel free to shout it out if there's anything in here that stands out to you. You can see the server-side code starts up here with the PHP tags. And I know live stream's a little bit behind, but the one thing that should stand out to you is right away we see this. We have if, it's a GET request, and it includes expert mode, then it's going to do TCP. And it's going to check to see if the port is open via TCP, and it's using netcat to see if the port is open. It tries to filter to validate the IP and to validate by the port, but we have a coding mistake here because we have a port integer here, but it's only looking at the port here and it's accepting user input for the port. You can see the command that it's running is user bin netcat IP port, and it's executing that command. So we have a maybe coding mistake here that instead of validating the port properly, we might be able to bypass that and just run anything on the end of this that we want. Knowing that it's running netcat, well, if you've ever done any amount of CTFs, you know that netcat can often be used to get a full reverse shell on the victim's computer. So let's go ahead and check this out. I am going to glance over my notes. I want to make sure I'm not missing anything because up to this point, I'm quite literally doing everything from memory. We'll make sure I am not doing anything wrong. I don't think I am up to this point, but let's go ahead and check this out. If we open up our browser, which is already right here, we'll keep this window open so we can look at the code as we do this. We'll jump over to this, but instead of index.php here, let's go ahead and try this expert mode equals TCP. And you can see when we do that, it says, hey, please enter an IP and please enter a port number. And that corresponds to the code that we see right here, asking for the IP and asking for the port number. Now, there was some interesting background on this. I'm going to stop sharing my screen just for a moment because I'm going to pull up Discord with JKR, who was the creator of this machine. And I think he would be okay with me sharing this. I'm just making sure I'm not showing anything private about our conversation. But yeah, no, this is good. Let me show you what he messaged me over on Discord. And once again, he is the creator of this machine. He said this. So what the code is doing, and you can see it up here, the escape shell command is documented here, and we saw that up there, and also has a warning. Warning, escape shell command should be used in the whole command string, and it still allows the attacker to pass arbitrary number of arguments. For escaping a single argument, escape shell argument should be used instead. It will only make sure that the string you give it is a single command by escaping the bad characters to get a subshell next command automatically. For the thing you skip, which is what I skipped when I did it, right here, and that's the port I called out. And I think, yeah, CyberNerd Dante just said over in live stream chat, unsanitized port. It is using int val on the port you give and then checking if it's a valid integer, if I could talk. But in the end, after validating it, the developer just uses the original port variable. What a pity, which is very real world. Developers often make mistakes like that because developers are people. And even ChatGPT, if they're developing their code with ChatGPT, also makes mistakes like that. So with that in mind, let's go ahead and think about what this is running. So if we open up our mouse pad here, we know that this is running netcat, and it's accepting an IP and a port number. So this is the command it's likely running. Netcat, IP, port. Now, what can we do with this? Well, if you know netcat, you know to get a reverse shell, you can easily do that. Do execute bin shell or bin bash, however you want to do it, and it should drop us into a reverse shell. So let's go ahead and try that. We'll open up our terminal here, and we'll do netcat mvlp 1337 because we are real hackers, and we'll put in our IP 10.8.4.163 and our port of 1337. But you can see I can't actually type, I can't do spaces. It's only accepting a number, but that is just client side. We could right click and modify that, but we'll just do it with our proxy. So go over to Kaido, turn on queuing, and click is it refused. Jump back over to Kaido. I'll send this over to replay so we can see it, and you can see our IP and our port. Now, keeping in mind is just executing this command. What if we add this onto the end of this? So if I do something like that and very easily add some URL encoding that way, let's give that a shot. We will click send, and the response hangs, which is always a good sign. And we jump over to this, and we have a shell on the machine. So we now have a successful reverse shell. Let's go ahead and grab this and drop it in our notes. We'll say reverse shell. and we'll drop the folder request there. But there is our reverse shell, and I will make a new header and we'll call it post-exploitation, and we'll begin doing some post-exploitation credential hunting, all of that fun stuff. Now, the one thing I want to show you again, remember I said Notion sets up a cool table of contents. You can see it up here. So if we wanted to review everything that we've done, we can very quickly look through this. And if I want to see, hey, what did we see when we did file read via curl, I can click into it and it will drop me down to that section. But let's begin now with some post-exploitation. Before we do that, we always want to stabilize our shell. Now, stabilizing your shell means it's going to give us a full TTY shell or interactive shell. So clear works. We can do things like SSH. We can do anything that requires interaction, which here it would not work for us. Deadpool said, I contacted Vulnlab for a year subscription, but they replied that 1 year sub is not something they are thinking about for now. Yeah, it says it's sold out on the 1 year sub. I was able to get a 1 year sub and then they changed it. I don't know why or the reasoning, but I'm guessing it's because the platform's doing well and they have more people than they were expecting sub, which is amazing. But here is our post-exploitation. Let's stabilize our shell. Now, if you've never heard of this extension, you need to check it out. It's called HackTools. You can literally just Google it. HackTools browser extension. It's for Firefox and Chrome. You can download it. The source code is on GitHub, so you can review the source code. But everything I see, it's all legit. But if you open up HackTools, we'll just make it full screen because I like doing it full screen mode. Whoops, I didn't mean to do that. I always forget the syntax for stabilizing a shell, so I always have to look at this, but they have it right here. So you can literally copy these steps to stabilize our shell. So let's go ahead and do that. We'll do that first. Step 2. Step 3 is Control Z. Step 4 is this. And then step 5 is this. There we go. And now we have a stabilized shell. We can clear. We can do things like this. Hoimino said, we're just redoing this box, right? This isn't deja vu. Yes, so I did the box like live methodology on stream, but this video right now is going to be the standalone video that will get posted on YouTube. Much shorter than me, taking 3 hours to stumble through the machine. But here we go. We have our stable shell here. And what I always do is anytime you get into a shell on a CTF machine is begin your enumeration wherever the shell drops you into. So in this instance, we're at var www.html. So if we lsla, what you're looking for is something like config.php or a database file. You can see we have the user flag here. So I'm not going to do it, but you can. I'm not going to show the flag itself on the video, but I showed you every step up to this point in order to get the flag. So if you're following along on your own, go ahead and grab that flag and submit it over on Discord so you get credit for the flag. But right here, there's nothing that's going to show credentials to us. So what I like to do is back out one directory and do it again. Is there any config.php, any database files? And there is not. We'll do it here. This is var, so probably not going to be anything interesting for us here. We can back out again over to the root directory, lsla. And from here, a spot I always like to check is the op directory. Often there'll be something here that you might be able to work with, but in this case, there is nothing here. Well, let's back out again. And the other place I always like to check when I'm looking for credentials on a Linux machine is home. We'll see what users are on this machine. We know from Etsy password there's an Alex user, and maybe we're able to dive into anything from the Alex user and figure out what we're able to do. So let's cd over to Alex. Over on live chat, Sodak said, your Kali VM is running so smooth. Do you have a reason why? My reason why is I use Ubuntu as my primary OS. I'm not even joking. I used to use Windows and all my VMs were buggy. They were laggy. They weren't smooth. I switched over to Ubuntu as my primary OS and run all my VMs on top of Ubuntu, and they work beautifully. Like Ubuntu runs Windows VMs better than Windows does. So the answer is if you're using Windows as your primary OS, it's because Windows sucks. Don't use it. But here on Alex's home folder, we see a few different things. One is we do have SSH, but looking at permissions, we are not able to actually look at SSH. Lots of talking. Need to grab a drink of water. So we can't go to SSH and try to get his private key. We will get permission denied. But looking at this, we have a .local, which is always something at least worth looking into. When I was doing this machine live on stream with blind methodology approaching this, this is something I missed and something that's kind of a mental note to myself. I did everything that I'm showing you right now, but I did not take the time to go into .local and figure out what was there. So let's go ahead and do that together. We'll cd to .local, lsla, and you can see we have a share here, which is quite interesting. We'll cd to share, lsla, and we have something called pswm, which is a directory. Maybe I would open my eyes, and we have it again. And this is some encoded string. Now, at this point in time, we should probably jot this down for our notes because, I mean, it looks important. It looks to be a mix of like base 64 encoding and something else just looking at it. Let's grab, I think, just this full thing for our notes, and we'll drop it here. And we'll say like analyzing PSWM file. There it is right there. But we don't know what the heck PSWM is. So let's just do PSWM. You can see my search history. Encryption, because we know it's encrypted. And you will stumble across this GitHub. It says PSWM. A simple command line password manager written in Python, built to be secure and encrypts your password with the key that only you know. But we don't know the key, but maybe we can decrypt it. If we scroll through, we can see how it's used. When running PSWM for the first time, you will be prompted to define a master password that will be used to encrypt your other passwords. If you forget your master password, PSWM will give you the option to reset it after 3 failed attempts. This would delete all your saved passwords since they would be encrypted with your old master password and impossible to decrypt without it. You should store your master password somewhere safe or choose something you will always remember. After choosing a master password, a password vault will be created as an encrypted file, blah, blah. Now, there is a script online that allows you to decrypt this, but what JKR told me is when he originally made this, that script didn't exist. So I wanted to go ahead and look at this and see the code. There's where it's having you guess it, manage master password. Lines encryption. We have some encryption stuff. I was curious. I'm not great at coding. I can do some scripting, but with ChatGPT, I can usually do most things. I had no idea, and I wanted to try this. This might fail miserably, but when I did this live, I just found a GitHub repo that allows you to decrypt this, but I wonder if GPT would be able to do it. Can you analyze how the decryption is happening and write a Python script that will decrypt it with a word list, the master password? This is more just out of my own curiosity if this would actually work. And we'll give him a second to come through with it. All right, we focus on the encrypted file to lines function, which uses the cryptocode decrypt method to decrypt the password vault with the given master password. The password vault is expected to be stored in a file, and the decryption hinges on the master password entered by the user. Here's how to create a Python script to attempt to decrypt the password vault using a word list. Read each password from a word list, attempt to decrypt the contents of the password vault file using each password. If decryption is successful, output the master password and the decrypted content. So let me just look at this code real quick. Crypto code sys, that makes sense. The pass vault file, so this will be the PSWM thingy that we found. We can set this to rocku.txt. It's defining a function here, decrypt with wordless, accepting the pass vault file and the wordless file. And it's just going through each one. It's opening the file, going on each line through rocku.txt, and then forward it's trying to decrypt it. Let's just try this. Once again, it might just fail horribly, but from my own curiosity, I wanted to know if ChatGPT could do it or not. So let me go here where we didn't discover any vhosts. And we'll do nano decrypt.py. We'll drop in the code there, and let's go ahead and grab it from our notes over on Notion. And we'll do nano PSWM. Like so. And now if we nano decrypt.py, so this is just PSWM, we're right in the directory. And we'll change our wordless file to user share wordless rocku.txt. We'll go ahead and save that and we'll run it. And you can see no module named crypto code. We actually saw that as a requirement. I don't know if that's going to break any dependency. So anytime I'm running custom Python craziness like this, I set everything up in a Python virtual environment. We can do that like this: pip3-m for module. We want a virtual environment. We'll just call it my environment. And, you know, maybe I should do this right. Like so is what I meant, not pip3, I meant Python 3. And then if we source my environment, you can actually see my syntax right there. And now we're in a Python virtual environment. Now we can do pip install crypto code. And it will install it. And now we can try to decrypt.py. And look at that. It was successful. It successfully decrypted the password. ChatGPT was actually able to look at the code for PSWM and within, what was that, like 10 seconds or less, create a decryption Python script that successfully decrypted Alex's password, which, amazing. Shout out to the robot, but we have it right there. We have the password. We'll go ahead and copy that password, jump back over to here, and you know, we could actually just SSH probably. We can SSH as Alex at down VL. And remember before we discovered it accepts password authentication, we'll put in the password and we now are Alex. If we do ID, you can see we're in the sudo group. We can do sudo su, drop in our password, and we are now root. If we go over to the root directory, lsla, you can cat out root.txt. I'm not going to show you the flag on stream, but I've shown you every step to get to the point where you are able to get the flag. So this machine was a lot of fun. I learned a lot through the process. It's cool. I was not expecting ChatGPT to, in one take, write a decryption script to decrypt it, but sure enough, it worked good. But hey, if you want a challenge for yourself, try to do that on your own. Right? See if you can look at the code on PSWM and write your own Python script to decrypt it just for fun as an extra challenge. But other than that, really enjoyed this machine. This is my second time going through it. So the fact that I've done it 2 times, enjoyed it as well. And I will just say, for those of you trying to learn, one of the best ways to learn is to teach what you have gone through. So someone said in chat, hey, is this deja vu? I just feel like you just did this, and it's because I did. I spent 2 live streams going through this room, and now I'm making a standalone video about this room and forcing myself to teach through it. I didn't even refer to my notes really from when we did it the past couple of the nights. I did all of it based off memory, and helps really cement the material in my own mind, so when I encounter something similar in the future, I'll remember what I did the first time, and I'll be able to hopefully solve the machine a little bit quicker. But hey, thank you so much for those of you watching this after the fact on YouTube. I will see you in the next one.